All right, you ready? All right, go ahead.
All right, folks, thanks for coming. We're very fortunate to have Brian Holman here speaking about TensorFlow and Kaggle. So with that, let's give a warm welcome.
Well, thank you for having me, everybody. I mean, that was a good enough introduction. That's basically what I'm here to try to brainwash you today. And this is kind of my mission statement for the talk today, is I'm here to convince you to learn AI. And no, you don't have to do this, but I'm not, I guess to give some type of background, I'm not an expert in artificial intelligence. I am not an expert in TensorFlow, and I've participated in a couple of Kaggle competitions. But I'm kind of an evangelist of those things because I'm super interested in them. I see how the demand in so many different industries is just skyrocketing. So I'm trying to get other people aware of that space because I wish I had found out about it sooner. So take that with a grain of salt. If you leave today and you're like, I'm not that interested, okay, then I wasn't trying to talk to you, I guess. But people that are super interested, that's kind of what I'm here today to do. So what I hope you'll know after the end of this talk is why you should listen to me, especially given that introduction where I told you I wasn't an expert in anything. Why should you learn AI? And if you are going to learn AI, why get started with TensorFlow? And what is Kaggle? And why should you be interested in that and start picking it up and learning it? So I'm going to start with why should you listen to me? And to preface that, I'm going to ask you two questions, and if I could get a show of hands, because I like participation. How many of you are here because you are interested in starting a career in technology or interested in changing careers? Nice, so virtually everybody in the room. I want you to believe that I'm just like you, or I was even just a couple of months ago. My PhD is in meteorology, which has a lot to do, there's a lot of technology and statistics that are in there. I mean, if you wanted to get into like weather modeling, then you better be a good Fortran developer because that's what they still run on. And no joke, yeah. So I've spent many a day stuck in the weeds of some old school Fortran 90 code. And so meteorology and technology are embedded, but how I ended up in my career now as a data scientist and data analyst, there's definitely some steps along there. And part of that was changing careers on my own and trying to learn lots of technologies that I use today on my own. So I just recently moved back to Portland. I'm a Portland native, but I did grad school in Florida on the East Coast at a tiny little school called Florida Tech. The people on campus was actually smaller than my high school, 12th and high. It was a tiny little place, but I went there because I wanted to be a professor and I wanted to research meteorology. And about the second year of my PhD program, I realized I did not want to be a professor. Now that I knew actually what it was and how many hours it was going to be and how much writing it is and applying for grants and you don't get to pick where you want to live and so many things, I was like, okay, so that's not the field I want to go into, especially since I was having kids and I wanted to get them back with their cousins, which are all up here. So long story short, I didn't want to do it. So then I thought, well, what am I going to do? It was kind of a time of dilemma for a good couple of months thinking, well, how am I going to figure this out? There are a couple of research institutions that I could get my PhD and I could do research for the rest of my life, which is cool, but then still there's only a couple places in the country that, where those positions are available. So then I heard a talk at one of our research groups about big data, which is a word that maybe some of you are sick of because we hear it all the time. But I was totally captivated. I said this was 3 years ago and didn't really know anything what it was about, but basically the skinny of it was, hey, there's lots of people that are getting master's degrees and PhDs in all sorts of these different fields, and then they're not going into those things and going into data science and becoming analysts for lots of these different firms for a variety of reasons. And I said, okay, that sounds cool. So I checked in to see how that industry was doing back home here, and it was starting to do well. So I said, okay, let's see what we can do, to try to get into this field. So from that point forward, I tried to, see how I could intertwine lots of the skills that I would need as a data scientist into the research that I did. So that's why I ended up researching, the use of statistics and machine learning and gradient descent to try to solve meteorological problems. And I kind of went from there. And learned. I had a couple classes in Java in grad school, but learned Python and R and Tableau and SQL and lots of the buzzwords that you hear around that space. So as I got more into big data and figuring, okay, what exactly do I want to learn how to do outside of just, well, I want to get a job and afford to pay off all these student loans that I'm racking up, is as I got really into that space, I became super fascinated by deep learning and artificial intelligence. And one of the reasons that I'm pitching you today, or at least why I'm an evangelist, is because it's not new, like the concepts are not new, but the technology that allows us to really apply it is only a couple years old. So this is a quick, just a nice handy chart that I did not create that talks about the history of artificial intelligence. So basically it has its origins in the 1950s, but deep learning and artificial intelligence as we know today really is a phenomenon of only the last 5 years to a decade. The Tensorflow that I'm going to talk about today was only released 2.5 years ago, or at least its open source version. It's developed by Google. So deep learning is a really hot topic right now. Artificial intelligence is a super hot topic, and like I said, I'm not an expert in the space. There are some people that said that the Google glasses would take off and everybody would wear them. They were wrong on that prediction. But lots of people that are a lot smarter than I am look at the future and say, dude, this is going to change the world, just like electricity. Just like electricity did. It went from checkers to cats. I don't know what the deal is with tech people and cats, but in all of the online courses that I did, it seems like building a cat classifier is a pretty hot topic. So one of these people that is way smarter than me is Dr. Andrew Ng, and he's a professor at Stanford, and has held posts in lots of different places. But so he's quoted as saying that AI is the new electricity, and he still says this even today. And the meaning behind that is, let's try to imagine our lives without electricity. I mean, so that's everything. Every single component of our life is impacted by electricity one way or the other. Even if we were giving this talk and it was just us talking to each other outside of this room, it would be miserable because, it'd be cold outside, we wouldn't have all of those nice advances that we could enjoy from electricity. And so the meaning behind this quotation is that 50 years from now, we're going to look back and think, remember when when we lived without artificial intelligence? And our grandchildren are going to laugh at us. So what are you talking, what does that even mean? I have no idea what you're talking about, a world without AI. And the revolution in artificial intelligence is already happening. Siri, Alexa, OK Google, all of those different frameworks, that's using artificial intelligence models that have been built on just massive data sets. And, so that you can just talk with it, and it's surprisingly pretty accurate. You can interact with these devices just as you would interact with another person, pretty much. This is the 2017 Chevy Bolt. And I'm going to contrast it with the next image on the screen, and I want you to look closely here and tell me what's different in the 2019 Chevy Bolt, as long as federal regulations are allowed. What do you notice it's different? No steering wheel and no pedals. They actually applied for this. This is what the car will look like if they are granted the ability to do it. Self-driving cars are already a lot safer than humans that self-drive. It's just we're more leery about it because it's technology, and that would be weird to just get behind the steering wheel of a car and then fall asleep and then wake up wherever you want to go. But that's within 10 years, like Elon Musk is quoted as saying, all the production vehicles won't have steering wheels in cars. I wonder if my kids will have to get permits, when they'll be able to just sit in the car and go without me. Weird idea. Lots of other sectors. Every nook and cranny of the modern economy will eventually feel AI's impact, from energy, transportation, healthcare, manufacturing, entertainment, education, IT, and the government. And the boom in AI development will lead to greater demand for hardware and services among growing AI developer communities. Basically, the idea is that there's no industry that this will not touch. And the good news is that this is still kind of the ground floor. we're not too late. If you're looking at this and I say lots of words today, which hopefully I don't, but if I do and you're like, what is he talking about? I feel like I should have learned this stuff years ago. I feel that way, but still this is an excellent time to start learning about these frameworks. This is a Google Trends that I got this morning that shows how often the keywords deep learning are searched for, and it's kind of hard to see this text down at the bottom, but you see a little flat, 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 and then starts skyrocketing. I mean, we're talking, this is 2014 right here, 2015, 2016, now. It's a very new thing. It's not too late to start learning what artificial intelligence is all about and the different frameworks. Another advantage of that is it's never been easier to get into AI. And, even just a couple years ago, if you said, hey, I've got this problem, I want to build, I'm going to use my webcam and I'm going to teach my computer how to recognize faces. That would take a PhD and years of development in order to get that set up and running properly. And now with some of the frameworks that have been developed, and I'm going to talk about TensorFlow only a little bit, you can do it in 100 lines of code in a weekend. Or somebody else has already done it, which that's true, and you can just get their code from GitHub and run it on your computer in a couple of hours. It's never been easier to get into this. It still takes a little while to learn, but it's super simple. So there's lots of different deep learning frameworks, and one question I suppose you could ask is, okay, what do you mean by a deep learning framework? Basically, you could still, if you wanted to go hey, let's take a couple years to do this, you could do all the linear algebra yourself in whatever programming language you want to do and build a neural network from scratch. But it's going to take you a long time. So lots of the major players, the companies like Facebook, Google, Amazon, Microsoft, have developed these rich APIs and frameworks so that you can, they do lots of the heavy lifting for you. You can just build these, really impressive AI models pretty simply. And TensorFlow is just one of those. It was developed by Google and released open source just a couple of years ago. And the reason that I am learning that one is there's a lot of demand for people knowing TensorFlow. It's of all of these different frameworks, it's the one that's most actively developed and has the largest community, which, yay, so there's lots of people that are working on it, but also if you have questions about it, it's really easy to get answers to TensorFlow questions because lots of other people are trying to learn it, so it's really active. And it's very scalable. If you have an Android phone, I'm sure they have TensorFlow on iOS, but since Android's more associated with Google, there are applications that can run TensorFlow just on a phone, and you can take that same application and using the TensorFlow APIs can distribute that across huge server nodes. So it's totally scalable and can run on completely different architectures with incredible speed. It also runs in your browser. So I'm going to do a little click here. This is a cool website called the Tensorflow Playground. And basically what we're going to do is you see this little, oh man, that's down really low. Here, let me pull this up here. Basically what we're going to do in just no time at all is, basically this is a website that has TensorFlow built into it. This is a neural network that is pre-constructed. You don't need to understand all this because I don't have that time to explain it and I'm still not an expert. But what we're just trying to do is, using a neural network, we're going to try to teach a computer how to recognize which dots are orange and which ones are blue. And so that if we were able to throw a new dot, say right there, it could tell us whether or not it would belong to the orange group, that's not a word, orange group or a blue group. And then it's not trained right now, and I can just train it in the browser. And all of these different nodes are using the data that has available to change what their predictions are. And the output, the classification output, is what you can see over here. And it's just trying to figure out, given the data that we've given it, how it would classify these different objects, and it's learning, and it's learning, and it's learning. And then eventually, it's going to get those two groups just spot on. There you go. And so it figured out, hey, everything in this spiral area is an orange dot, and everything in this spiral here is a blue dot. So cool site, Tensorflow Playground. So yeah, so you can run it anywhere. You can connect to it in almost any language that you're interested in. Super nice. So that was supposed to more just wow you and be like, what is he talking about? Let's see. And then also, because it is widely used now with TensorFlow, you can still get into the weeds and you can, specify, you do lots of the linear algebra yourself that is required to develop these cool architectures. There's also this library called Keras, which was developed also at Google, and it's something that runs on top of TensorFlow to make it just super simple. You're like, hey, if I want to add a dense neural network layer, you literally just say like, hey, add a dense thing, like almost in plain English, and it will completely respond to how you want to build your neural network library. So I wish I had a Model 2 for that, but I don't.
What is the neural network for?
What is a neural network for? So the neural network is essentially, let's see, basically it's linear algebra. It's a lot of matrices that are assigning weights to different neurons or nodes that are within the network. How many of you here are familiar with like linear regression and basic statistics? So the idea is that in linear regression we have lots of inputs. I don't want to get too mathy. We have lots of inputs. We'll say we'll just have 3 here, and in linear regression we figure out what weights to apply to each of these inputs to get some output. And so we could visualize this like this way. Each one of these will have a weight associated with it. And then we also add a term, what we would call the bias. So we assign a weights, and then we add a bias, and then that gives us some output value. So what a neural network is just a bunch of these. Each one of these little nodes can be represented as there are some inputs that are giving data to this node, and it assigns weights and biases to all of those individual pieces of information. And so does this node, and this node, and this node, and this node, and this node. And then you can have multiple layers so that all of these are talking to all of these nodes, and these nodes, and these nodes. So it's an excellent way to try to learn and represent data that is essentially nonlinear, like weird spirals, and trying to figure out the x and y coordinates on that, that are in that data there. Very high level thing.
It's kind of a pattern recognition.
Definitely, yeah, that's definitely a very common use case for it, is trying to recognize patterns, try to classify lots of different things. Absolutely, and so essentially so all you do in artificial intelligence is you train all of these nodes. Essentially, what the process that they use to do this is called backpropagation, but it's essentially just calculus and linear algebra. It's not that difficult to code. And you just teach it how to just play with the weights and biases a little bit until you get a result that works really, really nicely for you. So hopefully at this point, I've at least piqued your interest a little bit in artificial intelligence and convinced you somewhat that it's not too late to, nor is it too difficult to get into. I mean, I can learn it. I'm really not that smart. Don't let the PhD fool you. That just means I'm very comfortable with a lot of student loan debt. But the nice part is that, I mean, since there is a demand for people to learn this stuff, there are also interesting ways that allow you to practice these cool tools. And one of those is called Kaggle. And so Kaggle is a company that, and I'm going to let it tell you just a little bit. This is just a 1-minute video.
Today, top brands and leading organizations are leaning on data scientists and machine learning engineers to transform their raw data into problem-solving insights. But it's still very hard to execute this kind of work, let alone do it well. Finding interesting data can be difficult, and setting up a workable data science environment requires a tremendous amount of time. That's why we built Kaggle, a platform for the world's largest community of data scientists and machine learning engineers. On Kaggle, you can find and publish high-quality data sets, explore and build models with that data in our web-based data science environment. Connect and learn with other data scientists and machine learning engineers about problems and new approaches. And enter prize-awarding competitions to challenge your skills. Ready to join the world's largest data science and machine learning community? Click the link below to join Kaggle and get started.
So that's the long and short of what Kaggle is. It's a website where if you're interested in data science, it's a good spot to go play. Yes?
They said we make Kaggle. Who are we?
I can't, so, I mean, they used to be, they're a standalone company. Google owns them now. Google owns everything.
They don't know us.
They do not own us. But yeah, so I don't know who the original founders are.
Like Google.
Yes, but yeah, so they're part of the Google family of companies now. So it's a nice spot to just play with data if you're interested in the data science and AI space. Let's see. One really cool aspect about it is that it has a huge community of other people. If you are interested in learning data science and practicing these techniques, there are over 1 million people that are doing the exact same thing. And it's really easy to reach out to them. It's pretty collaborative, and there's people that are all over the world, that are having, that are struggling with these technologies just like you or just like I was, a couple years ago, and I continue to struggle with today. On top of that, there are really cool competitions that Kaggle hosts and that leading companies will sponsor. So for instance, like there's the 2018 Data Science Bowl is all about trying to use computer vision and build computer vision models to locate nuclei in microscopic images to improve, if we can do, apparently, because I've read a little bit about it, a great body of work from people that are doing lots of biomedical research is you got to look at, you have to look at the images that are coming your way, and then first you have to identify where the nucleus is, and then you can dive in further. So they're trying to develop an application that will get the nucleus for you so that can save the researchers a lot of time for whatever their use cases is. If you're interested in March Madness, there's a competition here that Google's sponsoring, and there's actually cash prizes that go along with if you win, and I've never gotten anywhere close to winning, so I don't even pay attention to any of these numbers over here. But, so lots of interesting problems that businesses do. Here's another one that is all about trying to detect when somebody clicks on an ad. They have these weird click farms where a bunch of bots will essentially go around trying to click ads for you, and if you are the person that has presented that ad and you're paying per click, then you would want not a bot to actually click on it, so it can be an engaging experience. So that challenge is all about trying to help this company figure out what is bot traffic and what isn't. So the nice part about this is that these are real business problems that are relevant to what's going on right now. It's not some toy data sets. Lots of these are huge, and some of them are a little bit cumbersome to work with, but it's more, at least it presents I'd say a stronger version of reality of getting into industry and tackling the type of problems that you'll find in there. And not to mention, so there's some of these competitions have thousands of teams that are all working independently, but they share a lot of their information with other teams so that everybody can learn together. They have these really cool thing called kernels. Are any of you familiar? I know that Tech Academy doesn't do Python, I don't think. Are you familiar with like Jupyter notebooks or whatever? So yeah, so there you go. So they host Jupyter notebooks, and Kaggle will take care of all of the package dependencies for you. So if you wanted to get on, like they already have TensorFlow installed, and you can run your code in their browser, so you don't have to worry about downloading the data. You don't have to worry about figuring out all the package information. You can just get on there and start playing with it right away. Which is really cool. So, I was supposed to have a conclusion slide. Dang it. So, yeah. So that's that is what. Oh man, how embarrassing. Hold on. So I'm going to go back to this really fast. Okay. So to wrap up what we learned today. Why listen to me? Because I was somebody that was trying to change careers and get into tech, and I very much was in a field that is not traditionally associated with tech, and it ended up working. I had to do it all by myself. I didn't know anybody that was trying to do the same thing, so I'm trying to help others along the way with the limited resources that I have. Hopefully, you will pay a little more attention to AI, and when you see Elon Musk get on and do things like launch his Tesla into space, and you'll think more than just like, that guy's insane, what's he talking about? It's like, oh, well, self-driving cars are a thing, and it's not just Tesla that's doing it. It's all of the automakers. It's super easy to get into, and TensorFlow is a great spot to start. And if you're interested in just practicing, Kaggle is an excellent playground to start getting more familiar with some of these technologies. I actually am part of a meetup that is here in Portland that's called TensorFlow Northwest, and so we're just trying. It's a free monthly meetup that really tries hard to teach people TensorFlow and doing it in Python. And there's one of the people that heads the meetup. He is the CEO of a company that he does this for a living. So he is the actual expert. If you have questions, he'd be a great guy to talk to. But then I run a little team that is a part of that group that just applies TensorFlow to Kaggle problems. And so we meet here. Tech Academy is awesome and gracious and lets us use their space twice a month. So we have a tiny little team. If you're interested, please reach out or come out. So that's our GitHub page, which has, if you go right there, the README on that page provides lots of resources for if you are interested and where to get started. And it's not something that you can learn super fast, but it is something that you can learn on your own, and we're trying to build a team. TensorFlow.org is a great spot to go if you want to learn more about TensorFlow, and that's Kaggle's website in case you're interested in there. But that is all I have, so if you have questions, please ask away.
So you've allocated getting into and exploring as a possible field. You're currently working in
Oh, yeah.
So
I have a job.
So can you share a little bit about so to help improve their scope of what this is potential? Could you share a little bit about your position, what you do with data science and the stuff that you're talking about?
Sure. So unfortunately, I don't get to use TensorFlow at work, which is fine. And really, that's only a product of the data that we're dealing with isn't big enough to be able to leverage deep learning. You need to have huge data sets. We don't have that yet. Maybe it's a thing for the future. But I work at a company called HealthSpark, and we're owned by Cambia Health Solutions. We're just downtown on First and Market. And so I work on the analytics and data science team. And essentially, HealthSpark has built a web app that tries to make healthcare more transparent. We try to provide, if you needed, let's say if you're like me, you just moved to the Portland area and you have a bum knee, which I do, and I need to get an MRI on it. I don't have a primary care physician. I don't know what places would be good. What provider is better than another one to, go get the service taken care of. And so HealthSpark has developed an application that it's contracted through insurance companies. So if you're an insurance company, like I think Regis is the only one in Oregon that works with us, then you can go online and go to Regence's website, go to find a doctor. That's our app there. And you can say, like, hey, I need an MRI. And it will show you all the places where you can get an MRI that are contracted with your insurance. And it will also estimate what your cost will be. And it will try to get you to choose the lowest cost on there, because some of those costs are super, super big. And we're trying to drive down healthcare costs by helping people make better healthcare decisions. So there's even some companies where we'll, so we pretty much try to incentivize better healthcare decisions. And so I work on the analytics team, and right now I am just trying to understand the information that we have. We have lots of Google Analytics data, because as people interact with our website, we get to see how they interact with it and try to use that data to make it a better experience for them, so that it's a lot easier to find what you're looking for and stuff like that. So I just started on that team a couple months ago. Like I said, I just graduated in December, and and I'm just super thrilled about what they're doing, and so far it's an amazing place to work. Did that answer your question for me? You have better ones?
How many people and what kind of positions are working in the team?
Data analysts and data scientists for our specific team. There's just 5 of us, and then there's another analytics team that has 6 people. So it's not huge. HealthSpark itself, I think, only has 150 employees. Cambia is much bigger, but yeah. So it's not a humongous company, but only a couple years old too, 4 or 5.
When you mentioned there's a million people looking at data analysis, you describe it as collaborative. I used the analogy of the U.S. election. There's half that voted for one person and half that voted for the other.
Okay.
How do you find the style that you work with and that you agree with, and that you want to, the different perspective. We're all part of the same country, but we're very divided politically.
Yeah.
And that can be true of software as well.
Yeah.
How do you make that useful?
So that's right. I'm supposed to repeat questions. So the question was, how do you build good teams with lots of conflicting ideas? Is that a good summary?
Okay.
Well, fortunately, my wife, she actually just finished her master's as well, and she's in human resources management. And she's shown me study after study after study that is, if you have a choice of being on a team that you completely jive with or a team that has lots of conflicting ideas, guess which one's going to be more productive if the people can work together without, ripping each other's heads off. The team with much more conflicting ideas. And the cool part about data science right now is it is a new, it's a newer field. Well, I mean, it's basically just statistics, and that's been around for a lot longer than I have. But data science as a big spot in industries, there's not, schools that are developing graduate programs specifically for data science is pretty new. So lots of people that say that they're in data science now have, physics backgrounds, biology backgrounds, art backgrounds. Data visualization is a huge thing. I encourage all of my friends that are big artists and, they went to school for that. I'm like, please get into data. Like some of these, like the software Tableau, I don't know if you're interested in that, but data visualization is a huge emerging space, and that's actually, being able to effectively communicate the ideas that we can derive from these data sets is something that data scientists struggle with a lot. So if you're a good storyteller, data journalism is becoming a huge field. I view opposing ideas as an advantage. It's obviously as long as you can work together in a non-competitive environment. I really like people. Maybe that's something that sets me apart from developers. Joke on developers. Just kidding. And so I really encourage competing ideas, but I mean, I guess that depends on the person on the team. But yeah, if you go into Kaggle, like I said, so for instance, I'm just going to pull up on there really quick. I mentioned really briefly the kernels that you can use. So let's say if you were interested in, if we go into one of the competitions that I've made a submission for, and I go to kernels, basically there are, let's see, does it tell me how many kernels there are? I don't think so. But what you'll find is each one of these represents code that somebody else has put up that can share their idea of attacking a problem. So if you're like, well, I don't know how to attack this problem, good thing there's thousands of other people that do, and they've shared how their approach was to it. So this way you can see a lot of different ideas and can really build on your, expand your tool belt for how to attack different problems and stuff like that. So this way, it's pretty open source. People want to share what they know, and I mean, I'm a big proponent of the best way to learn is by teaching. So this is an excellent spot for everybody to learn by teaching what they know to others. Was that a sufficient answer?
I think so. It's a good start.
If it's more into like how do you make people that disagree with each other work together, I am not the person to answer that question.
I think your answer is that it's a conflicting team that is collaborative is more productive than a homogeneous team. Right?
For sure. Oh, absolutely. Yes. Very much. At least that's what the social science research says. But I'm not a social science. Other questions? Yes.
So what advice would you give someone who is just getting into data science?
Mm-hmm.
I come from a physics background.
Awesome.
Shifting careers, sort of. So I'm assuming that we're not just going to jump into Tensorflow and understand everything.
Uh-huh.
So there's got to be a beginning point, and maybe you can tell us where you started, how you got to where you are, or if someone were to start today.
Yeah.
What path would be a most efficient path?
Sure.
To get to?
So I'll answer that two ways. One is you're not the only person to ask that question, which is great, and there are better answers than I can give from just my experience. I'll share my experience with you, but there is this gentleman named Suraj Raval on YouTube. He's a deep learning evangelist.
He's very entertaining.
Okay, so you know who he is.
Yes.
He actually has one of his most recent videos is literally, learn machine learning in 3 months. And so he literally goes over like taking like, okay, what online courses, what free resources would I use if I wanted to get to the point where I knew what TensorFlow was and could at least get into it a little bit in 3 months from now. And so the first month is like, I'm going to take these online courses about linear algebra and calculus, and then he goes, you know, then the next month I'm going to learn a lot about Python or these different programming languages. And so he's much more of an expert in this space than I am, and I mean he teaches actively on Udacity. So that's what he says, and unfortunately, you know, and that's only a 3-week-old video. So since the space is changing so rapidly, I think his words would probably be more useful than mine. What I did, because it was 3 years ago that I started this long transition over to data science, is I looked at the jobs that I wanted and saw what skills they were asking, and I said, okay, well, I know that I need to incorporate that into, you know, into what I'm doing. Like before I started graduate school, I'd never written a line of code. And I'd never done any type of sincere analysis, so I saw that I needed to do SQL and R and Python and get familiar with machine learning. So I was like, okay, let's make that happen. So I just poured over different courses and resources online, but almost completely free, you know, because there's lots of ways that you can learn this stuff. I think that boot camps are great. I looked at one for specifically what I wanted to do, but since I was already working on a dissertation and had kids at the time, it wasn't the right thing. So there's so many different ways that you can get involved, but I think that his answer would probably be the best way to get into there. But yeah, I mean, just learning new skills and then showcasing those skills, I would recommend. Unfortunately or fortunately, I spent a lot of time writing technical papers because I was in graduate school. So that's what I got out of graduate school. Unfortunately, I found an employer that was interested in the fact that I had done that. But I've also seen lots of other people that are trying to get into the space where they'll build a really, really cool application and then they'll put all the, get it hosted in Amazon so that it has its own URL so anybody can go to it and see it, and then they'll put the entire project up on GitHub so that when you walk into an employer, you're like, I can build this. What do you think about that? So that definitely gives somebody a lot more, more backbone than just saying, hey, I know this technology. That's some way that you can kind of prove it. Does that answer your question?
Yes.
Okay, cool, sure.
Oh, actually, I have a follow-up.
Yes.
So when I was first looking at this space,
Okay.
I noticed that everybody's talking about Python.
Yes.
This is NumPy, SciPy, Pandas, everything's Python.
Yeah.
I talked to a recruiter at Nike.
Okay.
And all she talked about was R.
Okay. Yeah.
And I said, well, when I was looking at this, nobody was talking about R, everybody was talking about Python. So
Yeah.
I don't want to waste a lot of time.
Yeah.
So I chose Python, and I'm sticking with Python. I just want to make sure that I make the right choice.
Yeah.
I can speak to that. R is, as far as data scientists, a lot of scientists use R prior, and a lot still do. It's a little harder to learn. Python is a lot more intuitive and easier for organizations to get their people up to speed on. So a lot of people have moved to Python as more of a way of helping adoption. So they're both usable for data science.
So if I've learned Python, or if I'm learning Python and really not looking at R, that won't hurt me really.
I don't think it'll hurt you. In fact, quite frankly, if you get hired and the company is doing R, it wouldn't be hard for you to transition over to R. So once you've got the fundamentals of Python, it's kind of like, do I learn on a stick or do I learn on a manual first? You learn on the manual first, and then going over a stick is a little easier because you know how not to run the road. And so all you're focusing is on the actual gear shifting. That's probably what you deal with when you deal with R.
I can't drive a stick shift. I grew up in New York City.
You can still drive, right? Yeah. There you go.
I learned R first because that's what my advisor and that's what my statistics professor used.
Yep.
And then once I got more into the space, so you can use TensorFlow in Python or you can use it in R, but it was developed with Python in mind. And in my experience, if you look at all the jobs that ask for either Python or R or both, most of them say Python. So, like I said, I learned R first, and then I was like, oh, well, it seems like Python's more of the hot topic, so I moved over to that space, and that's where I continue to go forward. So I would recommend Python just for that reason. Yeah,
and it won't hurt you. You get really versed in Python, get comfortable with it, and if you get hired and I'm paying you $80,000, $90,000 a year to do it, just learn R.
Yeah, but most of the other people that work where I do are R people, so yeah, tomato.
So
Any
What's the
questions?
difference between machine learning and AI, if there is a difference?
Basically, so the difference that I would say.
Good question. Repeat.
Oh yes. So the question was, what's the difference between machine learning and AI? I would say both of those are forms of artificial intelligence. Machine learn. So if the data that you're looking at is small and or pretty linear, like you could get a pretty good answer from just multivariate linear regression, and your data is small, there is no need to build some artificial intelligence model. In fact, even in more complicated questions, they have some pretty sophisticated, just what we would call classic machine learning techniques like random forests and support vector machines and k-nearest neighbors that are just as good as deep learning models if your data is small. And by I mean small data, I mean 10,000 observations, 100,000 observations. When you start getting into the observations that are in the hundreds of millions, deep learning is going to take the cake every day of the week. When you're able to build these huge neural networks that can really get at building really good models on very nonlinear data, that is where deep learning really shines, and that sphere of artificial intelligence really is much more successful. So that's why, and the capabilities that we've had to employ those models in a way that's very fast and efficient is something that's only been able, we've only been able to do like the last decade. So that's why we hear a lot about it now, because it's, lots of people are jumping on the deep learning train. But yeah, so for small data sets, yeah, lots of the machine learning will do just fine. Good question. Yeah, sure. Any other questions? When's my next meetup? We are supposed to meet, let's see, so the main Tensorflow meetup is, the next one is in the middle of April. If you want to, let's see, did I even post a website? So if you want to go to the website, trying to zoom in, but that does not change this bar. So yeah, so just go Tensorflow Northwest meetup. And so it looks like our next one is
March 30th.
Oh, hey, there's one that is, yeah, so March 30th, and then we also have one, so the next Kaggle team that I'm hosting is April 7th, which will be here, and then our next, monthly group one after that, too, is April 18th, and so far we're starting to build a pretty cool community of people that are pretty interested.
So you mentioned twice the Kaggle group that you did here. What exactly do you do?
Right now, we're just, it's a bunch of people that don't really know TensorFlow and or Kaggle. So we're trying to get everybody a little more accustomed to that space and involved. My vision for the future is that we'll have a nice team of people that can collaborate on those Kaggle competitions. And we'll just get together. Not only will we work in our spare time, but we'll get together and, just talk ideas for approaching a particular problem and, code kind of hackathon style and try to solve these things. And yeah, that's the vision for the future. But right now, we're just trying to get everybody up to speed on.
How far away do you think are you from that?
A ways. A ways. If you still feel like you're a beginner, it's a whole bunch of other beginners. So one way that you could look at it is that it's the blind leading the blind, or you could think, teaching is the best way to learn, and so we're all just trying to help. A lot of everybody has lots of different knowledge that we're all trying to come together to get this going.
Are you aware of any group in Portland that maybe not beginner level, but intermediate level, but also want ultimately to participate in Kaggle competitions?
I am not. I know that they've had them in the past. I'm not aware, but that's just because I haven't looked. So there could be. There very well could be. Portland's a pretty good place. Good question. Yes.
So what's the role of the mathematical knowledge? I mean, I've looked a little bit of this since it's all just prepackaged libraries. There's actually no tensors here.
What is the role of the mathematical? So I would say the real role is the understanding, and I'll give you a biased answer since I'm an academic, right? If you walk in, you'll be like, tell me about meteorology, and I'll be like, well, you see, and then I'll start going all over the board on theory because that's my nature. But you know, I would say the role of understanding how all that linear algebra works is it really gets you integrated into understanding how these networks work, so that when there's a problem or when you need to make different changes to your neural network architecture, you have some meat behind that instead of saying just, oh, well, somebody else did this, so I threw together this, I built this graph and I ran it. It gave me an answer. Let's just try something else and just kind of do random search. But if you're interested in that and learning all of, the tensors behind it and how they're interacting and all that, linear algebra, then I think it's worthwhile to look into that. But I'm a nerd, so that's the answer that I have to give. Good question. Yes.
So you're kind of designing the architecture, but then the machine is going to build its own algorithms based on the neural architecture you devised for it?
Yes, yeah. It will figure out the weight. You specify the architecture, like how many layers you want, how many nodes you want per layer, what type of optimizer. As in, there's typical gradient descent, or you can apply momentum or decay, or or RMS prop, atom. So there's different optimizers to learn that, and you can specify the different parameters, like how fast it should learn, and you pretty much the world is your oyster. But then once you tell it to run, it will compute all the back propagation on its own to pre-train or to train all of those weights for whatever, depending on whatever data you're feeding it.
Can it share the rules it came up with?
Absolutely, yeah, and that's one other really cool thing about TensorFlow is transfer learning. So like there's, if you're interested in the tech space, like they have this competition every single year that's called ImageNet, and it's where it's a classic data set of millions of images, I believe, where lots of different organizations, companies, researchers will build these just huge neural networks that try to do a really good job at classifying these images. And what you can do with TensorFlow is so if they use TensorFlow, then they can save that neural network, that graph, all of those weights, and they'll post it on GitHub. And then so you can just take it and then utilize all of those weights that they've trained on massive GPUs over weeks, and then just apply it to whatever problem you are. You can even make it so that the weights don't get touched for many of the layers, and then you can tweak the architecture and the last couple of layers and output, and just take all the work that they've done and apply it to your own problem. So that's one advantage of using an architecture, a framework like TensorFlow as well. Excellent question. Any others?
Any other questions? All right, well, feel free to ask him some additional questions. Let's give him a warm thank you for his time. And if you're new to Tech Academy, if you could fill out a survey about your experience today with this Tech Talk, it'd be greatly appreciated. We'll share it with Brian. And thank you for coming.
Thank you. Yes, thank you.